Hello guys, let's do a practice problem involving reaction stoichiometry and the ideal gas equation. So the question is, we have baking soda which decomposes at 80 degrees Celsius by the following reaction. What volume in liters of carbon dioxide gas at 1 atm pressure is produced by the decomposition of 10.5 grams of baking soda? So because we have to calculate the volume, we know instantly that we need to use the ideal gas equation, which is PV equals nRT. And because we have to solve for volume, so we can rearrange this equation. Volume equals nRT divided by P, the pressure. So let's take a look at all the variables. Do we have the temperature given to us? Yes, we do, right? We are at 80 degrees Celsius. So T, temperature, equals 80 degrees Celsius, which we can convert into Kelvin by adding to it 273, which is going to give us 353 kelvins. Are we given the pressure? Yes, we have the pressure. We have 1 atm pressure. Okay. Do we have the ideal gas constant? Yes, so the R value, we can look at this nice little table here. We can match it up with the units of the pressure as we usually do. And because the pressure is given in ATMs, we are going to use this value for R, right? All right, what else is there? Well, we are missing the number of moles, right? So we have to figure out the number of moles of carbon dioxide gas produced. How can we do that? Well, let's use reaction stoichiometry. Because the grams of baking soda is given to us, we can calculate the moles of baking soda and use the equation to figure out the moles of carbon dioxide gas. So let's start with the grams of baking soda, which is sodium bicarbonate, NaHCO3, which is a solid. And in order to convert it into moles, we need to have the grams of NaHCO3 on the bottom and the moles of NaHCO3 or baking soda on top. We know that 1 mole is actually going to be 84.01 grams, which is simply the molar mass of baking soda. So after this, we can use the balanced chemical equation where we know that if we have 2 moles of baking soda, we are going to produce 1 mole of carbon dioxide gas. So let's put that into a fraction. We have to convert the moles of NaHCO3 into the moles of CO2. And from the equation, 2 goes here and 1 goes on top there. Let's double check the units. Grams cancel out, moles of baking soda cancel out. So our final unit is going to be moles of carbon dioxide. This is exactly what we were looking for. And if you do this calculation, you are going to get 0.0625 moles of CO2. Okay, so we have the number of moles. The last step is simply plug everything into our equation up here. So the volume equals to the number of moles, 0.0625 moles of CO2 multiplied by R, which is 0.0821 liter ATM divided by Kelvin times mole, and this multiplied by the temperature, 353 kelvins, and divided by the pressure, which is 1 atm. Okay, let's double check the units. The kelvins will cancel out, the atms will cancel out, the moles will cancel out. Our final unit is actually liters. Excellent. So if we do this calculation, we are going to get 1.8 liters of carbon dioxide gas. Okay, I hope this makes sense. See you in the next video.